Okay, ladies and gents, the last video was a little bit longer than I was planning for, so I gave you a bit more time to get through that. This is our last week. The Undertaker has quit wrestling, and we will soldier on to the end. What we're going to do today is we are going to go over the task that was set in the last video, just quickly go over that. Then we're going to go on to some of our definition for what a base is, and our common acids that we need to know, and we'll wrap up with a little bit of a fun task for this week. I'm going to do a video for you guys and the advanced tires about where we're at with the coronavirus, so hopefully that'll be done by the end of the week. I've got some tours in school to do for our P7s that are coming up to S1, so that video should hopefully be done. I'm hoping by Wednesday, Thursday at the latest. And if you're interested, you can watch it. If not, I'll give you a different kind of task to do. But let's get started. So the task was first to balance. I've put brackets round my complex ion here, or the complex within the molecule. That may or may not be there, it doesn't really matter. I'm going to skip putting the state symbols in just because I ran out of space trying to do this the last time. So once again, what I asked you to do is balance this, and we're going to do metals, non-metals, hydrogen, then oxygen. So the metal that we're playing about with here is sodium. Our non-metals, well, we've got sulfur. Hydrogen, we do have hydrogen, and we've got oxygen. So on this side, the number of sodiums I've got is 1. I've got 2 on this side. I've got 1 sulfur on this side. I've got 1 sulfur on this side. Hydrogens, I've got 2. Oxygens, I've got 5. Oh, I've got 3. Ooh, 3. 1, 2, 3. So that was almost a horrible mistake. 2 and 5. Right, so this balancing equation really gets to the heart of why you need to use these, because this one's a bit more nasty. It's a little bit more complex than the last few that you've had to do. So the first one that's out of whack is the metal. So I'm going to put a 2 there. That's going to give me 2 sodiums, but it's going to increase my number of oxygens by 1. So I've now got 6 of those, and I've now got 4 hydrogens. So that's done. I want to move down. Sulfur, that's still fine. There's no major issue with the sulfur there. Hydrogen, now I've got a 2 here and a 4 here. So what I can do is put a 2 there. That's going to take that up to a 4. Then we're going to have 2 plus 4, which is 6. Now it's balanced. And that's how you would balance that question. Once you've balanced it, there was another question, and we will take a look at how to do that. So that was if 20 grams of H2SO4 sulfuric acid was added to a beaker of 500 milliliters, what would the concentration be? Right, so the first thing that I want to do is I've got a concentration question. So from the front of my data booklet, I will see that I get this equation, and I wouldn't mind converting that into a triangle just to remind me how this all works. Now, I'm being asked for the concentration, so that's my question. I've been given the volume. It's in milliliters. I will have to convert that to liters, so that's going to be 0.5 liters. Now, I've not directly got the moles, so I need to work that one out. So, to work that one out, I'm going to need a different equation, and that equation is N equals M divided by GFM. Now, that is our moles, that's our mass, and that's our GFM. So once again, I can convert that into my little triangle. And I told you we would be doing these all throughout the year, and we just keep doing them. So we've got mass, GFM, and moles. I've got the mass, that was 20 grams. Now the GFM I don't have directly, but I've got the molecular formula, so I can work it out. So H2SO4. So that hydrogen is going to be 1 times 2 plus 1 times 32. And I'm just going to double check that. I think it's 32 in the National 5 data booklet. Yes, it's 32.1 in the advanced higher one, but we don't need to worry about that. Plus 4 times 16. Now, that is going to give me the gram formula mass, so that's 2 plus brackets 16. That equals 98. So that's going to be 20 divided by 98. And that equals 0.204. Now, that is in moles. So now I do have this, and that's 0.204. I'm going to keep that in my calculator, and all I'm going to do is divide it by 0.5. Start that again, 0.204 divided by 0.5. So that is going to give me 0.408. Could make that equal to 0.41, and that would be moles per litre. And I'd double underline it. So even though my working's all over the place, I've double underlined it to show them that that's what I want them to mark, and I've got my little unit in there. So that is how you would do those two task questions. Right, today is going to be pretty straightforward. It's going to be notesy, but shouldn't be too much hard work, and I'm going to give you something that's a little bit more light-hearted at the end as a task. Okay, so we're just going to do some basic notes, then I'm going to throw down a task. Now, we've already gone into alkali solutions, and that if a solution has more hydroxide, OH negative ions, it will be alkali, and you will be able to test for that using universal indicator, and the universal indicator will go blue. The pH will be anywhere between 7.1 and 14. It's a scale that actually goes past 14, but we don't use it past 14 at this stage. So if we've got a metal oxide, so one of the interesting things is you can burn metals. Metals will combust. You would have done that in S1 when you did the magnesium. When you burn that magnesium, you go from this silvery metallic element to the compound, which is kind of this white powder magnesium oxide. So if, and it's a big if that metal oxide dissolves in water, it will form an alkali solution. Not all metal oxides will dissolve easily. So you've got to take a look at the data booklet and a little bit on the data booklet that tells you whether or not a compound will dissolve. So metal oxide plus water gives you a metal hydroxide. That's a very basic word equation that we will take a look at these when hopefully we get back to doing practicals. A lot of this I plan on going over when we get back. In fact, we're probably going to go through the whole thing in quick step, just so we can do all the experiments and things as well. So a metal oxide plus water will give you a metal hydroxide. Now you could extract that metal hydroxide, and if you then place that metal hydroxide into water, if it was soluble, that would also create an alkali solution. So metal oxide or metal hydroxide will give you a nice alkali solution. And what we can say about that is that when those substances are placed into water, they will increase the number of OH negative ions or hydroxide ions, creating that alkali solution. So what I want to do is shift on to bases. Now, what you've got to remember with a base is that it will neutralize an acid. All metals are bases. So all metals are bases, and metal oxides, metal hydroxides, metal carbonates, and ammonia are bases as well. So one of the experiments that you'll probably have seen before is the alkali metals being placed into water, and you get this release of hydrogen gas and they burst into flame. Now, the reason we are not allowed to do them into acid is that reaction would happen much, much faster, because those metals would react to neutralize that acid very, very quickly. So metals, in fact, I think if you could add in metals to your list here, that would be good. In fact, I will make an amendment, because metals are also bases. So, somewhere. Probably better at the start, but it's in there. So all of these will neutralize acids. The metal carbonates, calcium carbonate will be the one that we will use quite a lot. That is our CO3 2 negative complex ion attached to a metal. So that will also neutralize an acid. And all you need to be able to do is classify what a base is in your head and classify what an alkali is in your head. So if the metal oxide dissolves, that would form an alkali. If it doesn't dissolve, it can still act as a base, because if it doesn't dissolve, it's not going to release OH negative ions. So just be able to play with that concept in your head. Think about whether or not something is just a base or it's a base and an alkali. All alkalis are bases, not all bases are alkali. Right, last little bit is our common acids, and this is either going to be mono or di. It'll release either one proton or 2 protons. And what I mean by that is you're going to either release 1 H positive into solution, or you could release 2, and that's going to have a big effect when we do some titrations later on. So nitric acid, you've got the complex ion NO3, and you've got that hydrogen will dissociate, and that's what will increase the number of H positive ions. In fact, I'll put a little dotted line around that hydrogen. That is what will go on to make the H positive ions increase. So that will dissolve. Essentially, the H will plop off into solution, and it'll wander about creating that acid solution. Hydrochloric acid we've got our monoproton hydrogen, and it's attached to chlorine. That'll dissolve once again. When it dissolves, it will increase the number of H positive ions that we've got in solution. Vinegar or ethanoic acid, that's a little bit more complicated and a little bit trickier, and we will go into this. This is actually a weak acid, and we'll cover this in a lot of detail later on. These hydrogens are not involved in increasing the H positive ions. It's only the hydrogen that's attached to here. Now, what this looks like is, if I draw out the actual that hydrogen is popping off that oxygen. So that's the full structure. That hydrogen will pop on and off that oxygen, and when the hydrogen's off of it, the H positive ions will increase, and you'll have an acid environment. And we'll talk about this, but it's in something called a dynamic equilibrium. So it is, if you've got 10 of these molecules, maybe 5 of them have the H that's plopped off, 5 of them have the H that's still attached, and they will be always in a ratio of 5 off, 5 on. But it might not be the same molecules that have it attached and have it plop off. But that's something that will take a little bit of time to talk about, and I don't want to do it over video. I think if I was going to do it, if we do need to do it over video in the future, the whole video would be about that. So I wouldn't worry about that quite yet. We will move on to it. Lastly, sulfuric acid. We've got 2 hydrogens in this case that can plop off. Now, that actually means that we're going to have 2 H positives for every 1 molecule of sulfuric acid. That does change how sulfuric acid works in terms of the concentration you need to neutralize any given alkali. For example, because these ones only drop in 1 hydrogen, you would need twice the volume or twice the concentration of these to neutralize the same amount of hydroxide ions that your sulfuric acid could neutralize. But we will, once again, we'll go into that in a bit more detail later on. All that I want you to get from this is the names of the common acids that we talk about, what they look like, and their other potential names as well. There are, and it is a problem in chemistry, we do have an old discipline here. This is kind of hundreds of years of, well, at least a couple of 100 years of effort and work from humans, and the words we use have changed over time, but we still have relics and colloquialisms as well to make things easier for people that aren't directly involved in science. So, last but not least, we have the task. Now, this one is just a bit of fun, just to chill out with. You can pick any acid you want. Doesn't have to be one of the 4 acids that we spoke about. What I'd like is the structure. Remember, if you've got a complex ion, they don't work with the valency rules that we've talked about. So just look up a picture from the internet and copy it. If you don't know whether or not it's correct, just email it through and I'll let you know. Some basic info, the gram formula mass, the boiling point, anything else you want to chuck in. Uses, so in this particular case, putting on your chips, and any other info that you'd like to put down about that acid. There's lots and lots of different types of acid. There's some really cool videos that I will link to about some different acids, and just take your time with it. This is the last week. You guys have done really, really well. I've been slowing down a little bit. The numbers watching the videos have kind of come down, and I actually don't want us to get too far ahead of the people that are maybe lacking a little bit behind. I really have appreciated all the feedback that I've been getting, and I appreciate the effort that you guys have put in. Has not been easy, but you have been doing really great. So just keep the chin up, keep going.